Hi, now I'm going to explain project Phoenix, a MapReduce implementation with new enhancements. The main aim of this project is for MapReduce implementation for shared memory machines. The main objective of this project is to develop the application to evaluate the design and the prototype of Phoenix performance as well as Phoenix limitations. Big data can be defined as huge as well as compound data sets that contain a lot of unstructured as well as the structured data that are large, very fast, very difficult to manage or organize through using the traditional techniques. MapReduce that Google has prevalence is an efficient, simple, fault tolerance and scalable data processing tool that is independent from any other data storing system. In the existing system, storing high volume data is not a big challenge due to the advancement of data storage technologies such as the boom in cloud computing. However, securing the data is very challenging. The disadvantage of the existing system is if the big data storage system is compromised, it can be very harmful as individuals' personal information can be disclosed. In the proposed system, our system module, however, to obtain the values from the data, sometimes the data need to be shared multiple times with different companies. As different companies have different cryptographic keys, the data need to be decrypted and then re-encrypted again, which not only has computational overhead but also has the possibility of data leakage. To solve these kind of problems, we need to encryption techniques which allows data sharing between different parties without decryption and re-encryption process. This is the architecture of map reducing technique. And the hardware and software requirements for this project is firstly in the software requirements, firstly the Eclipse is the IDE is the integrated development environment. With the help of this we can able to develop the web applications as well as the Java applications. It will give the standard directory structure. Then this is the project. Here these are the packages. Inside the packages the servlets are there. For the front end view we are using the JSP pages, and this project is developed based on the MVC architecture. MVC means model view controller. It is a software design pattern for developing the web application. A model is the lowest level of pattern which is responsible for maintaining the data. View is responsible for displaying all the portion of the data to the user, and the controller is the software code that controls the interaction between the model and the view. And here we are using the Tomcat as the local server. And for the Adobe STFS interaction from the Windows, we are using the Sigwin tool. Here in the Sigwin tool, with the help of this Sigwin tool, we can able to easily interact with Adobe STFS from the Windows environment, because it will support only for the Linux environment. So in the Sigwin terminal we need to run the commands of the Adobe. This is the Adobe STFS. Here whatever we are going to upload, those files will be uploaded here. Now start the Tomcat server. Localhost is the local system IP address. 8080 is the port number of the Tomcat server. These are the list of the deployed projects. Here this is the index page of the application. Here the admin login and the user login privileges are there. So we are using the MySQL as the database, and the SQL log is the interface for the MySQL. This is the database of the project. Now the admin can able to view his profile, he can edit his profile, and he can able to change his password. And then he can able to create the new users. Then these are the hash code details. Then the transactions. Then here we are implementing the B plus trees. Here for each and every B plus tree, the key value pair will be there based on the hash table. The unique key is the hash ID and the respective value is the hash code. Based on this, while downloading, based on the keys of the B plus tree, we are downloading the files and we are merging, and we are getting the original files to the client. Just log in with the user. User can also view his profile, he can edit his profile, he can able to change his password. Then these are the uploaded files. The files will be uploaded in the form of the blocks. Let us upload one more file. Now the user is going to upload the image. This is the image he is going to upload to the Adobe STFS. While uploading, the image file will be divided into the chunks. For each and every chunks, we are generating the hash code. Then we are assigning the unique ID for the unique hash codes. Based on this, we are maintaining the key value pair. Key is the ID of the hash code and the value is the respective hash code. File will be successfully uploaded. Then this is the file stored in the block format, the image file stored in the block format. While downloading, the image will be come in the original format. means the blocks will be downloaded based on the B-tree plus. This is the original image. This is Phoenix, the MapReduce implementation with new enhancements. Then the user can able to view his transaction details. Sign out. This is the project. Thank you.